Hello and welcome to Getting APIs to Work. In today's video, we'll talk about how to bridge the difference between different versions, how to make it easy for your users to transition from one API version to another. There are easy ways and not so easy ways of doing it, so we'll look into some patterns how to do it. So come with me and follow me to my office. Okay, now let's talk about designing APIs for extensibility. Why is it important? It's important because your API is a product. It's a product that somebody consumes, and what you want to do is you want to make it easy for somebody else to consume that product, and making it easy also means that if you make any changes to the product because you want to, let's say, improve it, that you do not break existing consumers of the API. And the more you focus on extensibility when you design it, the more you can actually keep that promise that you will design it in a way that is not breaking people, or only when you really have to. This goes back to the discussion we had about API lifecycle management, where the idea is that an API evolves over time and you will have different versions because you want to improve the API over time. But then the question is, if you create a new version, do consumers actually have to adapt? And ideally, they don't have to, because you're managing those changes in a non-breaking way. One good scheme to do that, and that's another topic we discussed already, is semantic versioning. So semantic versioning is this idea that you have major, minor, and patch version numbers, and that only the major version numbers are actually breaking changes. Semantic versioning really is a good thing to use, but it absolutely depends on the ability to have non-breaking changes. If your API cannot evolve, then every change will be breaking. That's almost by definition. So what we're looking at here is really this idea of managing APIs as products, managing their change over time when they go through different versions, using semantic versioning and making it as easy as possible for consumers to not have to adapt unless they want to look at new features that you release. And we look at what this means for you as a designer. Before we go deeper into the details of how to design APIs for extensibility, a brief note about API styles. We discussed API styles already. There are 5 different styles, and the design considerations that I'll be discussing today apply to all of these styles. But the examples I'll be using and showing mostly are, I would say, most relevant for the resource-oriented style. But regardless of which style you're using, each of the styles have good ways of designing for extensibility. And when you look at the styles, so we looked at 5 styles, and then when you look at the styles, you can just look at their main abstractions, and those abstractions then should be your place where you design for extensibility. So let's very briefly go through the styles. The first one was tunnel style. So what is the main abstraction in the tunnel style? It is functions that you're calling, is basically remote procedure call. So designing for extensibility in that case would just mean that you say there may be more functions that I release over time. People who don't care don't need to know about those functions, but the existing functions will continue to work as they did before. Second style is the resource style. We'll discuss that in more detail throughout this video. So in the resource style, the main abstractions are resources and their representations, and extensibility then means you may have more resources or you may have richer representations. So you may change representations over time so that the same resource returns actually a representation that has more information in it than it initially had. The third style is the hypermedia style. In hypermedia, we have kind of the similar concepts that we have in the resource style, but we also have links. And for extensibility in the hypermedia style, we use the same approach as for the resource style, but we also may reserve the right to add new links or to start using new link relations so that your representations then contain links that point to new resources, for example, that were not available before, and that would be a way how you can extend a hypermedia API. The fourth style is the query style. In the query style, the main abstraction is the query language and the schema that it depends on. So in that style, the extensibility method really means extending the schema so that your queries can return additional data, more data. You can have new queries into data that you added over time. And the fifth style is the event-based style. So the main abstractions in that style are events and the representations that those events carry in their messages. And those also are the two main extension points. So you may add new event types that are used when something happens, when you start evolving the API, or you may add details to a representation and say the event is the same, but the representation that represents the event actually now contains more details than it did before. So that was a brief overview of how APIs and extensibility works for all of the 5 API styles. Now let's jump into a little bit more detail on how API and extensibility actually works. And as I said already, we'll focus mostly on the resource style because that is the most popular style that you see in APIs nowadays. And to give you a short motivation of what we're doing here really is this idea, and I said this already, that APIs are products. The most important thing for an API is to be consumed. So you have to be aware of consumers. You have to be friendly to consumers. That should be your goal, that you make it easy for consumers to consume your API. And an API, to some extent, you could say is a promise. It's a promise that you say something works. You can access it over here. It works this way. And consumers then start using it and hopefully they find it useful. Now, if you break this promise, that makes it very hard for consumers. And in particular, if you have many consumers, then you break promises to many consumers and they all have to adapt. So it becomes really expensive to do that. So you really want to minimize it. And the way to minimize it is to make a promise that has certain evolution points over time, where you can say, I promise to do this, but things may change here and there, so be prepared for those things to change. And then consumers can understand your promise and those extension points, and you have a more loosely coupled relationship with them, so you can start evolving the API along those extension points, which means you can improve the product, but at the same time existing customers can happily continue using the product until they really want to check out what is new. Then they can go and look at the latest version, but if they don't want to look at the latest version, they can just happily do whatever they did before. So that really is the goal here. So how can you achieve this goal? And it's relatively easy, really. The most important thing really is to keep in mind that you have to start planning this from the very beginning. That is really the most important thing to keep in mind. Make this part of your API practice. Make sure that everybody designing APIs understands the importance of this and that this becomes just part of good practices that everybody is using. And then you really can make APIs much more useful than they otherwise would be. So when we look at how to do this, there are 3 main things to keep in mind. And if you keep those 3 things in mind, you can design APIs that are designed for extensibility, that can evolve over time, and that will be better APIs than if you didn't do that. The first thing to keep in mind is to start with a meaningful product. To say you design an API, often this is what people say, an MVP, a minimal viable product, where you say this is the minimal product I can come up with that makes sense for people to use, that I can release for users. And that is the initial promise that you make. And that promise is important because from then on, you say, this is what I promise my API will be doing. By releasing this meaningful initial product, you are able to attract consumers. You are able to gather feedback about maybe what other features they would like to have. So this allows you to get a product out, to start having consumers, to start gaining feedback from consumers, and then over time you can improve the product. And that is what the next 2 points are about, not just starting with a product, but also then having the ability to improve it over time. The second aspect is to have well-defined extension points. And the extension points depend on the API style. They depend on how you define the API, which technologies you use. They also depend on how you document it and where you want to evolve the API. So extension points really should be strategically placed. And these are the points where you say, I reserve the right that in these places the API may change. And as I said in the beginning, we'll focus on the resource style here. So for the resource style, very often the extension points are that you say, I may add additional resources over time, meaning that new resources become available. And that is rather easy for people who are not interested in those resources. They will just not know about them, but that's fine because they're not interested in them. And B, the other thing that may happen as an extension point in resource-oriented APIs is that you will evolve representations of resources, meaning that you probably start with something like JSON, and then you say there's a certain data model associated with your representation. There's maybe a schema for it. And then in that schema, you specifically point out places where additional data may show up. And in that way, people are very easily able to understand that right now this representation looks like this, but over time it may change. There may be new properties showing up, and they can prepare for handling those or at least safely ignoring them. So that's the important part there. So this second aspect is this idea of clearly documenting where you intend to evolve the API. So creating and documenting those extensibility points. And the third aspect that sometimes is a little bit forgotten, but I think it's important, is that there has to be a well-known processing model. What do I mean by this? Processing model means that in the second point we said there has to be an extension model. That's fine. But then the question is, what are consumers supposed to do with those extensions? So if I am consuming the product and then the product evolves and something new, let's say, shows up, what am I supposed to do? And this is what a processing model tells me. It tells me if something shows up, then you must ignore it and it's fine to do so. So this must ignore is one important processing model, and I think it is the one that you should use for all of your APIs. Another popular model that you sometimes see is must understand, which means that you say if something new shows up, you must understand this new thing because it may be very important, and if you don't understand it, you should stop processing. This is a model that works. It's just not a good model for APIs because it doesn't allow this backwards compatibility. It breaks everybody who must understand the new thing and doesn't understand it, and then they just have to stop using the API. So you want to avoid that. So focus on must ignore as the processing model. And one implication of this processing model, which is also important, is that because must ignore tells consumers that if something new shows up that you don't know, it's safe to ignore it. This implies that whatever shows up cannot change the meaning of something that is already there. So what do I mean by this? For example, if you have a number and that number is, let's say, some measurement, and somehow the implication in your API is that this measurement is in centimeters. What you cannot do is now to evolve the API, have a new property that says inches, and then imply that this means now that the measurement is actually in inches. Because that would break existing consumers who assume that the measurement is in centimeters and they ignore this new label that says, no, it's actually inches. And they would misinterpret that measurement in the API. So you cannot do that. So the processing model is really important, and it should be documented explicitly so that API consumers know that it is safe to ignore whatever shows up that they don't know. And that means that you can add these additional properties, for example, and you can safely evolve the API and existing consumers will not be disrupted. That was it. So we looked at the 3 things that are really important for designing APIs for extensibility, which are a meaningful core, then extensibility points, and a processing model. A last word about implementing those things. So one thing I would like to point out is that it really helps when you have any kind of test environments, test cases that you create for people consuming your API, if you include some, let's say, made-up extensions in those test cases or in a sandbox that you create, because that allows users of the API to be prepared and to test their preparedness for the cases when you start evolving the API. So if you do that, this really helps long-term with the stability of the ecosystem, because you make sure that everybody who implements the API actually implements the processing model in the right way. So that's one thing about implementations. The other thing about implementations I would also like to point out is that if you do create libraries or SDKs for your APIs, then it's a very good idea to add something to that SDK or the library that actually signals that there is an extension. If you do it like this, then somebody using the SDK can write code that realizes that something changed in the API, and they might write it into a log or raise some warning, or they can do whatever they want to do, but at least there is a path that goes from the API through the SDK to the application on top of the SDK that makes it possible to program some logic that manages the case when something new shows up. You probably still have to adapt the application, but at least you can do something meaningful to, like I said, maybe just raise a warning or write something into the log that says maybe we should look at what the API is doing now. That was it. That's all I had to say about designing APIs for extensibility and evolvability. It's rather simple. I think the hard part really is a little bit to make it part of your design practice, and I think that just becomes more natural over time. But if you follow those 3 steps, starting with a meaningful core, designing extension points, and designing a processing model, then I think you're really much better prepared to manage your APIs in a good way over time. What that allows you to do then is to manage the API lifecycle in a way that as long as you can make those minor version changes, you can safely do so because you remain within the bounds of your own extension model. And if you realize that you have outgrown your own extension model, then you have to bump the major version. It becomes a breaking change, which at some point is unavoidable. Every product at some point is outgrowing its lifetime, right? So you will have to do that at some point, but trying to do that as rarely as possible, that's a good goal to follow. Now, if you have to do this, if you start realizing that now I really want to do something with my API that is not covered by my extensibility model, then it's very useful if you can signal that to your consumers and say, we will actually deprecate this API and we will shut it down because we realize that we want to move on to a different model. Everybody will have to adjust to that. And if you can signal that to your consumers, then you also have a good way of managing this transition of the life cycle. Having the end of life of one API and transitioning over to a new major version. For this, you need something a little bit different. You need mechanisms of how to manage deprecation and how to manage the end of life, the sunsetting of APIs. And this is also something that should be part of good API design practices, but it's not something we'll discuss today. It'll be part of my next video. So for now, we're done with the API lifecycle. I hope you enjoyed it. If you did, please like the video, subscribe to my channel, and I'll be back with deprecation and sunsetting pretty soon. See you.